Okay, so welcome to this video where we're going to focus on vectors, that is part 2, specifically vectors in 3 dimensions. Okay, so in the previous videos we've been talking about vectors in 2 dimensions, that is for x component as well as for y component. Okay, so for this one, like I said earlier, I said we're going to focus on vectors dimensions. Okay, we are focusing on vectors in 3 dimensions. Alright, just a recap. We understand that in 2 dimensions vector, we are normally focusing on the x as well as the y component. Suppose we have this as our resultant, which is r. Then if you want to resolve this one with respect to the angle, we use to say this is going to be my x equal to r cos theta. Remember, the angle cut by the axis cut by the angle carries cos. Okay, and then this one we used to say it has to be y equal to r sin theta. Okay, so this is our simple recap to what we did in 2 dimensions. Then how do we find the direction as well as the magnitude for this one, how do we resolve this one into its components? We normally use what we call analytical method for us to understand it fully when it comes to finding the direction as well as the direction as well as the magnitude of a given vectors. So mostly analytical method applies if you have more than 2 vectors. Analytical method applies if you have more than 2 vectors. Now we are going to discuss more about vectors in 3 dimensions, and it's very rare for this type of a vector to be solved using analytical method. Hence, we have special methods that we are going to be using in solving questions based on this type of a vector. Okay, so how do we put this one? We found that we're going to put it as follows. We are going to have r, which is the vector, and this r normally we resolve it with respect to x component, then y component, something like that. So here we are going to have r cos theta, there we are going to have r sin theta. That is according to vectors in 2 dimensions. Alright, now today our main focus, and before I even go to the next step, if they ask you to say what is the resultant for this one, or rather the magnitude for that one, we say r. You can have rx, then ry, depending on the number of vectors that you have. So to find the resultant, we normally use this formula, which is the root of rx square plus ry square. Now in this video, we are going to focus mainly on vectors in 3 dimensions. What does it mean? On top of these 2 different axes, they have introduced another important axis, which is also called the z-axis over the same over the same 2 given axes. Okay, now how can you draw, or how do you know that this is a 3-dimensional vector? So I'm going to draw something like this. I have this as my x-axis. I will also have this as my y-axis. Now the z-axis, it is being introduced at this given point, this given point. So this is my y-axis, this is my x-axis, and this becomes my z-axis. Our main aim is to make sure that this z-axis is making 90 degrees with each axis, 90 degrees with respect to each axis. It's more like you're having things like this. To know clearly where z-axis is going to lie, I would like to draw this kind of thing, a cuboid. This is my cuboid. Okay, my cuboid is going to be drawn as follows. We have a line here. I'm also going to have this line. Then I'll have that point. I'll definitely have this given point. Then I'll also connect this point. I'll also connect, or I'll draw it at somewhere there, and then I'll do like this. Okay, also I'll do as follows, like this. So I'm going to understand that if you continue here, we're going to have this line. And then if you connect this line and what is on that part, find that this line and this line will connect. And then this line and that line are going to connect. So what I'll do, I'll draw depending on what I'm from explaining on top there. This is going to be my z-axis. If you continue with it, I'll do it like this. I'll make it darken a bit, like this. And this one becomes my y-axis, and this part again, this becomes my x-axis. So this is my x-axis. As you can see, this becomes my y, this becomes my z. My main aim is to make sure that z-axis is making 90 degrees with respect to each axis. So we can have 100 and also we can have 90 degrees with respect to the x-axis, and also I'm going to have 90 degrees with respect to the z-axis, I mean with respect to the y-axis. So this is what we call 3 by 3, or rather 3-dimensional vectors. We are having 3 different axes. Now someone might end up asking a question to say, how do we find the same resultant for 3 by 3 vectors, and how do we come up with the direction of the 3 by 3 vectors? I know that out of what I'm from drawing here, I'm going to have something like this. This is my z-axis, this is my x-axis, that is my y-axis. So suppose the resultant is at this given point, which is R. By the way, for you to find the resultant, you have to find the resultant with respect to 3 different axes. Meaning that you say resultant is going to be based on, you say a root of, you start with x square plus y square plus z square. So these vectors, they won't even require you to have an application of resolving them into components. Why? Because they are components already. Why? Because they lie into each axis. So this is how we find the resultant of 3 by 3 or 3-dimensional vectors. That's how we do find their resultant. So if it comes to the issue of finding the angle, how do we find the angle? You're going to understand that the angle between the resultant and the x component, or rather the x-axis, it is labeled as alpha. The angle between y as well as the resultant, it is labeled as, we call it as beta. Then the angle between the resultant and z-axis, we call this one as gamma. So I'll say the angle between the following, between the x-axis, sorry, I have this one, so I should see between the x-axis, comma, y-axis, and z-axis are alpha, beta, and gamma. I think you still remember what's the meaning of respectively. If you haven't heard of this gamma word, it means everything is equivalent to the first thing has to be equivalent to the x-axis, which is the first, second beta, third gamma. So all these angles, they are found with respect to what, to the resultant. All right, now how do we find the same angle? So you find the angles with respect to each axis. You find the angles with respect to each axis. So you start here. The only identity which is being used is what we call cosine. Reason being, cosine is the one which mostly supports the starting point, which is from the resultant, in short. Yeah, so we use the identity of cosine to find the angle with respect to each axis. Now, how do we find the angles Suppose you have been given a vector which is having, in short, it is 3 by 3 dimensional. So since 3 by 3 dimensional vector, it has x, y, as well as z axis. Automatically, for you to find the angle, you're going to say cos alpha has to be equal to, you say x axis of that same vector divided by what? Divided by r. Then you say the other one for y, you say cos beta, this has to be equal to y over the resultant. Then you go to gamma, which is z axis, you say cos gamma has to be equal to z over the resultant. This is how we find the angles with respect to each axis. Now, I know that the best way of writing this one, you can just say r square, it can also be equal to x square plus y square plus z square. You can also write it like this. So for us to get that one, meaning that I had to do what? I have to square root on both sides. Alright, we move a step further. Now, here a question can come in to say, prove that cos square alpha plus cos square beta plus cos square gamma. Let me try to write it down here. Prove that cos square alpha plus cos square beta plus cos square gamma is equal to 1. Then they can even put 5 marks. So for you to clearly understand at this moment of time, you have to use what we are from doing. We are saying, what do we use for us to find the angle? For us to find cos alpha, we are saying it has to be equal to x over r. Yeah. And then for us to find cos beta, we are saying it has to be cos beta has to be equal to y over r. And then for this one, which is gamma, you are saying cos gamma has to be equal to z over r. So definitely meaning that where there is cos alpha, I can replace with this. Where there is cos beta, I'll replace with that. Where there is cos gamma, I'll put this. But once we square them, they're going to give us a separate meaning. Definitely, we're going to have x over r. I'm now replacing where there is this, that, and that one. So since this is squared, I'll also square this. So I'll say plus y over r. I also square that, say plus z over r. I also what? I square that. My main aim is to come up with 1 for me to acquire these 5 marks. So we are going to square both on top as well as down. You find that it will be r, sorry, it's going to be x square over r square plus y square over r square plus z square over r square. So a simple mathematics that we can have, if we say a over b plus c over b, how do you handle out such kind of mathematics? This is just one and the same, like a plus b, or sorry, a plus c over b. Why? Because the denominator is common. Definitely that's what I'm going to do even in this given part. So what am I going to do in this case? I'll say x square plus y square plus z square, you divide throughout by r square. So getting back to that identity which I gave you, sorry, getting back to the formula of finding the magnitude of the resultant, which is r square is equal to x square plus y square plus z square, meaning that where there is this, I'll definitely replace with what? I'll say x square plus y square plus z square. Where there is this, I'll put that formula that we are using to find the identity. I mean, to find the result, the magnitude of the resultant. In this case, I'm talking about this formula to say r square is equal to x square plus y square plus z square. All right. Okay, so this means that in this case, where there is this, I also divide out by what? By x square, y square plus z square. So this into that, automatically you're going to get what? 1. And you say, hence shown. You get your 5 marks. Now, here we have some of the notations that are used under 3 by 3 vectors, even when it comes to 2 by 2 vectors, or rather 2-dimensional vectors. We also use the same notations. So we have 3 different notations. So the 3 different notations. So these 3 different notations, they come in with respect or corresponding to each axis. So I'll start. X-axis is represented by a notation I. Then the same y-axis is represented by a notation J. Then z-axis is represented, z-axis is represented by letter or a notation K, meaning that a vector that can be given can be represented in these notations, which is what? This, that, and that one. So suppose you have an example. If an example has come like this one, so let the vector A, which is equal to 3i minus 2j plus 5k, be a 3-dimensional vector. Then if they say find so the best way to help everyone of us in here is just to do like this. Okay, so if they say find the angles between each axis. So we are going to understand that, like the way I've written this question, we have vector A, which is equal to 3i minus 2j plus 3k. So in simple ways, this is your x-axis, that one is y-axis, this one becomes my z-axis. So before you even start solving for the so-called the angle between each axis, what you should always do is you need to find the resultant, because the formula that we are from using, we are saying for us to find the angle between each axis, you need to have the x component, or rather the x value, in this case, which is 3. You come to -2, that is part of y, which is this one. You come to that one, which is z, we have 3, and you're going to use this formula. By the way, we are saying cos, we don't use cos anyhow, but for these 2 remaining identities, you can punch them using a negative directly, and you are going to get the actual angle. Alright, so we proceed. So we're going to have r equal to, you say, the resultant of x square plus y square z square. So the resultant in this case is going to be equal to the root of 3 square plus -2 square. Sorry, this has to be 5. Sorry, made a mistake. So I have 5 here. So what you're going to understand is this. You have 3 square plus 2 square plus 5 square, getting 38. Alright, meaning that the resultant in this case has to be a root of 38. this is my resultant. If you want, you can even do as follows, just by saying square root of the answer, and you'll be able to get your answer as that is 8.16. So my resultant here can be 8.16. So definitely, to find the angle, we're going to find the angle as follows. Okay, so for you to find the angle between x component, or rather x axis, and the resultant, you have to say cos alpha has to be equal to, by the way, vector A is equal to 3i minus 2j plus 5k. So I'll start by finding the angle between this and the resultant we are from finding, which is, in fact, sorry, we made a mistake here. This has to be 6. It has to be 6.16, not 8 now. Alright, so definitely you have x over the resultant, then this one I'll say cos beta, it has to be equal to y over the resultant, then cos z, cos gamma, it has to be equal to z over the resultant. So this is going to be equal to, if you reach where there is negative, you can just plug in a negative direct, you'll be able to get the actual answer. So this is going to be 3 over 6.16, and this is going to be equal to, that is negative 2 over 6.16. This is going to be equal to 5 over 6.16. So I'll start from the top part there. Definitely I'll say alpha in this case is going to be equal to cos inverse of 3 over 6.16. Because here beta is going to be equal to cos inverse of negative 2 over 6.16. Then there gamma is going to be equal to cos inverse of 5 over 6. So the angles now are going to be, alpha is going to be equal to, so I'll start punching one by one. I'll say shift cos inverse of 2 divided by 6.16. What answer are we going to get? So we are getting an angle of 71.1 degrees. Beta, you have to get your beta as follows. So you say for beta, you're saying cos inverse of negative 2 divided by 6.16. Okay, definitely we are getting an answer as 109 degrees. And for gamma, we're going to get, you say cos inverse of 5 divided by 6.16. Like this, we're going to get 35.7 degrees. Alright, so these are the angles with respect to each axis. Someone can even ask you a question to say, why is it that these angles, they do not add up to 360? The reason is very simple. We are trying to find these angles with respect to every axis and not with respect to positive x-axis, as in you start moving counterclockwise. Now we find the angle with respect to this axis by finding that angle, with respect to that axis, which is this angle, with respect to that axis, which is the angle in between. So this is how we do find the so-called these angles, even the magnitude. So in conclusion, just say you have to know how to point out which one is my x-axis, which one is my y-axis, which one is my z-axis, and know the notations. After doing that, the formula is very, very important. This formula, that formula, and also this formula. 3 by 3 matrix, we don't use tan to find the angle for each axis. Hence, we use these given formulas. Thank you for watching. This is where the so-called vector in 3 dimensions ends. We are going to have more questions and more examples down here. You can try to solve them out as you're trying to practice. Thank you.